Welcome back, students, to the sixth part of Mathematical Tools in Physics. The important tools in mathematics that we were trying to understand in order to make it simple to have a clear understanding of the different concepts of physics for class 11. Up till now, we have understood the important concepts of quadratic equations, binomial theorem, logarithms, trigonometry, and differentiation. So today we will discuss an important branch of calculus, that is integration. What is integration? To make it simple, we can say integration is the reverse of differentiation. This means the steps followed for integration is just the reverse of differentiation. In fact, the result that we obtain after differentiation, if we integrate that result, we will get back the original function. That is the meaning of this statement. Whenever we differentiate any function, we obtain the differential coefficient. Now, if we integrate that differential coefficient, we can get back the original function. This will become a bit more clear when we discuss a few examples that will prove that using the differential coefficient, whenever a function is differentiated, we obtain the differential coefficient, and once we integrate that differential coefficient, we can get back the original function. Now the symbolical representation of integral sign is shown. This symbol is used to denote integration. If fx is the differential coefficient of a function fx with respect to x. If fx is the differential coefficient of a function fx with respect to x, then we can write down dy by dx equal to, obviously, the differentiation of this function, and as per our assumption, it is represented by fx. Therefore, can't we write down dy equal to differential of fx, and that is equal to fx dx. Now this is the expression for differential dy. Now if we take the summation of all the differentials, taking summation of all the differentials, we will get summation dy equal to summation fx dx, and that is further equal to summation of differential of the function fx. Therefore, y will be equal to summation of fx dx, that is equal to fx. Now when dx approaches 0, the summation is replaced by integral. So when dx approaches 0, this summation is replaced by integral. So now we may write down y equal to is further equal to function fx. This entire thing is read as integral of fx dx, where fx this is called the integrand, while fx is called integral or permittive function of fx. Thus, integration of fx with respect to x is fx. Here we should remember that the method of integration is used to sum up the effect of a continuous varying function. Before we discuss the examples based on integration, we have to know some fundamental formulae. Using these, we are going to actually understand how integration is carried out. Now here I would like to mention that amongst all the important expressions, this is going to be used more often. So you need to remember this by heart. Okay. So integral x to the power n dx is equal to x to the power n plus 1 by n plus 1, where n is not equal to minus 1. This is the result that is going to be used more often. So this you need to remember by heart. Integral x to the power n dx is equal to x to the power n plus 1 by n plus 1, where n is not equal to minus 1. Like for example, if you are writing down integral dx, then integral dx may be written as integral x to the power 0 into dx, because anything raised to the power 0 is 1. Now using this particular formula, in place of n we have to substitute 0. So this will give us x to the power 0 plus 1 by 0 plus 1, and this will give you x. So integral dx is equal to x. Similarly, if we are having integral c x to the power n dx, where c is a constant, then obviously the constant can be taken out of the integral, and straight away we can write down the result as this. Suppose we have to find out the integral of x to the power minus 1. Then obviously we cannot use the previous expression, because in the formula itself it has been mentioned that n cannot be equal to minus 1. So what about this expression? Integral x to the power minus 1 dx. This can be written as integral dx by x, and the result is actually log x. Another important integration is this one. So in this manner we can have many important fundamental formula of integration, and you need to remember the standard integral so that it becomes convenient for you to apply those results straight away when doing any derivations. I would like to repeat once again that the topic of integration will be covered in detail in mathematics in standard 12, but for the time being in physics, as we have to do a lot of derivations using the concepts of integration, so it is very important to remember these standard integrals, and the most important one being this one. This you have to remember, because in most of the chapters, in most of the derivations, you will find that we are making of this particular standard integral. Indefinite integrals. If a function of x is given by y equal to x to the power 5 plus a constant c, where c is a constant of integration, y is equal to x to the power 5 plus c, where c is a constant of integration, then dy by dx will be equal to this much. And obviously when we differentiate this, we will get, and that is equal to 5x to the power 4. Now as integration is the reverse of differentiation, so integral 5x to the power 4 dx should be equal to how much? X to the power 5 plus c. But if we make use of the standard formula, then integral 5x to the power 4 dx is equal to actually x to the power 5. It means during integration the constant does not appear. It is due to the fact that the differential coefficient of a constant is 0. Hence, we cannot say definitely whether integral 5x to the power dx is equal to x to the power 5 or x to the power 5 plus c. Such an integration is known as indefinite integration. Therefore, in all the indefinite integrals, a constant of integration c is supposed to be present if the condition of integration, that is the limit of integration, is not mentioned. Therefore, we should add a constant c in the result of all indefinite integrals. Like for example, you are asked to integrate this function. So how we are going to do it? Put to z, ax plus b equal to z. Then d by dx of ax plus b will be equal to dz by dx, as z is equal to x plus b, or a dx will be equal to dz. Therefore, dz by a is equal to dx. Therefore, integral 1 by ax plus b dx is equal to integral 1 by z dz by a. This is equal to 1 by a integral dz by z, that is equal to 1 by a log of z plus the constant of integration. Now we can substitute the value of z, so that will give you so in this manner we can integrate by substitution of the constant of integration, and that is what I was referring to as indefinite integral. Now this is the method that has been followed to solve this particular case is integration by substitution. This is an example of integration by substitution. Let us consider one more example. Suppose you are asked to integrate x to the power n log x dx. So how we are going to solve it? Now this may be written as log x into x to the power n dx. It's the same thing. Now in this case what we do, we are having two different functions. See, two different functions. So whenever we are having this sort of an integral, we can use a method. Identify the two functions separately. Let us write them as u and v. So we can integrate them as, suppose in place of log x I am writing u, and in place of v I am writing x, in place of x to the power n I am writing down v. Then this expression will reduce to uv dx. So integral of uv dx, this will be written as u integral of v dx minus integral of differentiation of the first function into integration of the second function into dx. This is called integration by parts. Now let us apply this result in solving the question. So going back to the question, it was integral log of x to the power n dx. So that may be written as log x integral x to the power n dx minus integral differentiation of log x into integration of x to the power n dx into dx. Now this will be equal to log of x. Now what is going to be the answer for this part? Integral x to the power n dx is equal to x to the power n plus 1 by n plus 1, isn't it? minus, let us keep the solve the remaining part. So d by dx of log x, d by dx of log x is 1 by x into x to the power n plus 1 by n plus 1 dx. So now the first part will become x to the power n plus 1 into log x divided by n plus 1. We are simply multiplying these two terms. And the second part will become, you can take out 1 by n plus 1 out of the integral sign. You can take this 1 by n plus 1 out of the integral sign, and inside the integral you would be having x to the power n dx. How do we get this? See, x to the power n plus 1, and in the denominator you are having x, so you can write down x to the power n plus 1 minus 1. So the term remaining will be x to the power n. So this will give you x to the power n plus 1 log of x divided by n plus 1 minus 1 by n plus 1 into x to the power n plus 1 by n plus 1 plus a constant of integration. Now we need to solve it. So this will give you x to the power n plus 1 log of x by n plus 1 minus x to the power n plus 1 by n plus 1 whole square plus a constant of integration. You can take out x to the power n plus 1 by n plus 1 as common, so you will get log x minus 1 by n plus 1 plus a constant of integration. So this is the second way of solving an integral, that is called integration by parts. Now we are having definite integrals. When a function is integrated between definite limits, like for example integral a to b fx dx is a definite integral of fx between the limits a and b. So this will be written as and that will be further equal to I will give you one example to understand this better. Now, before giving you the example, I would like to mention one important thing, that no constant of integration is involved in the integration of definite integrals because we are aware of the limits. So, suppose you are asked to solve this. So, this will be equal to so this will give you 1 by 3 log of 1 plus, in place of x you will substitute 2 first of all, and then 0 in the second case. So you are left with 1 by 3 log of 7 minus log of 1. Now we know that log of 1 is 0. So 1 by 3 log of 7 minus 0. So that will give you 1 by 3 log of 7. So in this manner we are going to solve the definite integrals. I will suggest you to solve few problems based upon the different formula of integration so that it becomes much more easier to understand what is integration, how to apply the formula, specifically the expression that I asked you to remember because that will be the formula used quite often in case of derivation or different formula in physics. Apart from that, you can try solving few questions from indefinite integrals as well as definite integrals. This will be the last session in mathematical tools in physics, and taken together all of these will be used while deriving different expressions in physics. So from our next class we will formally introduce the topics to be covered in the syllabus of class 11 physics. But you should practice more and more questions based upon all the mathematical tools in physics. That will help you to have a clear understanding when we start deriving the expressions in the coming chapters. Thank you.